Hi, welcome back. So in this video, we're going to talk about CDIS compliant DM demographic datasets for clinical trials. Okay, so before we start, we should need few documents to continue with this R programming by using the R language. So the first one is SDTM application, and the next one is SDTM CT, we call as control terminology, and the next is SDTM IG implementation guidelines and annotated CRF. And for reference, we need protocol. Okay, so this document we should need before we start to do programming. Okay, so let's open each individual documents, make sure we have all of them here. Okay, so I already opened one of the documents here because as a specification is the TM. So here we have different domains, the DM, supplementary DM, EX, AE, BS, LB. So basically we're going to derive, we're going to assign our to map these data sets. Okay, and thereafter we have control terminology. So basically, if you need to submit the SDTM or any values for the variable, we should follow some control terminology. So this is, we have a client specific control terminology. So this is basically we need to submit for sponsor value, like for submission purpose, we need to have the format similar like this control terminology. Okay, so the next one we should have a SDTM implementation guideline. So here we have a general information, like this is kind of Bible for the SDTM. So we have general structure of each demographic dataset. So here we have a DMXPT. This is a kind of version 3.2. So for each, this dataset will have one record per subject. So for each row will be having the one record for each individual subject. So here we have variable names. So we have individual variable names are here. Then thereafter we have a variable label. So for each variable we have to label based on this implementation guidelines. So there we need to the data types, like for variable, how do we represent in either character format or numeric format. So we need to have this standardized format. Okay, so here we have a control term. So we have ISO 8601. This is for the date format. So in the date format, when you submit any dataset, we should have in this format. Okay, so we have a role for each individual variable. So either it's identifier or topic record qualifier. So based on that one, we have to like this is kind of representing the each variable. So there they have some CDIS nodes which we don't which is very important, we have to consider. Basically this is giving the general nodes. Okay, then after we have a core. The core represent either required, expected, or permissible variables. So this is we already discussed in the generalized format of SDTM video. So I won't go more on this topic. Let's continue with the programming first. Okay, so to get the raw data sets, we need a raw data set. Basically, if we go to the folder we have, so here we have raw data folders. So this is raw data set. So we need to get this is in the SAS dataset format. So we need to import into the R environment by using the R syntax to convert to map, to get those data sets into the to read those data sets into the R environment. Okay, let's start with the DM datasets. So before we start DM datasets, we need to have the header part. Okay, this is a similar kind of how we do in SAS programming. Let's grab this one first. Okay, so here we have to develop the DM dataset. So we keeping the input, so either demo raw or exposure raw. So these two raw dataset we are going to use. Okay, one and this one. So as per the specification, so here they have mentioned, they have given the nodes. Based on these nodes, either we're going to derive, either we're going to annotate based on the CRF, or we're going to represent origin with the protocol or CRF. So assigned. So based on these ones, we're going to do our scripting. I mean our programming. Okay. So here we have SDTM datasets. That is output. So we're not going to use any macros. So the first name and last name, either you can, if you have any modification history, you can use the first name and last name. So I'm just copy this part and paste it here. Because this one, I don't need to save it. So I save this part. Save it somewhere here by creating one new folder. Okay, so in that we're gonna create one more new folder, SDTM programs. So in that we keep it as DM. I hope you understand all of that. Okay, so before we start, we should know something like our language should be always be understand the basic concepts, basic sub concepts of different factors, different data types, or syntax or functions. We should have to know before we do continue with the clinical. I'm not going to teach those things or basics part here. I'm going to explain only the clinical, how we derive from the raw data sets. Okay? So to set up the environment, we should need a few data sets, a few programs. I'm sorry. Okay, so here it won't work like that. So we're gonna give something like this. Okay, let's continue with this one. We're gonna use RN, which is basically to clear all objects. If you have any data set previously is been present, because this is the environment we will be having, all the data sets will be here only. So this is the console environment and this is the files. So we don't need files right now at the moment. So I'm gonna keep it as minimize. We're gonna continue with these ones. And remember, there is no semicolon at the end. Okay. We're gonna import few packages which are already installed in my RStudio. So you make sure you have installed those ones first. Library Heaven, tidyverse, then library deployer, lubricate, library admiral. Okay, so here let me explain these libraries. So these libraries, the RM is to clear all objects from the R environment. To first start, in case if you have any datasets are present, if you need to remove those ones, we have to use this syntax. Okay, and there is a library we have to install first in the RStudio before we continue doing this one. So the Heaven is used for reading the SAS dataset, SAS7 btat files, and the tidyverse is a deployer for data manipulations, and the lubricate for handling the dates and times. Okay, and for Admiral, we usually decide to design any clinical data processing. So for these operations, we need to install these packages. So in order to execute these ones, we just put control enter. Control enter. You can see here is coming like library Heaven. All those are executing. So if you don't have those syntax are here, okay, that is fine. So if you don't have your the packages in package was installed on your RStudio, it will give an error here. Okay, so right now all the packages are installed in my RStudio. So for that, I don't need to go back and explain how to install all the stuff. For now, I'm going to continue from here. Okay, so first we need to set the working directory. So set working directory by using the set wd function. So the basically you set the where you want to how do you say, where you want to down, like save all your documents, those stuff. Okay, so here I'm going to take this part and we need to change the path something like forward slash. So we don't use the backward slash, otherwise it won't work. Now you see the setwd is working, and now we have to check the if our working directory is right or not. So we can use the get wd function. and it will give you the what is the working directory we are working. So here we have ER clinical course. So now we got the right working directory. Now we're going to continue with setting up the path. Okay, so we're going to use the path to access the raw datasets. Okay, we're going to give the name as a pathra, and here we have a symbol called okay, so this is our symbol. The arrow symbol, it represent for assigning the operator. Okay, this is assignment operator. Basically you are assigning your path to the pathra for the variable. Okay, so here we're going to access the raw data sets. So we're going to go to the raw data set where we have save. So the raw data sets are here. Raw data sets. Copy copy this link. Then we're gonna paste it in here. Okay. Now we execute control enter. So now we have access all your raw data sets here. So basically setting for file path, the set for work directory. Okay, then after we're gonna define the raw data sets right now, raw data files. So to reading the raw data files, we're gonna use the function called read SAS. Okay, so the DM datasets assignment operator. So read. This is a function basically we accessing the raw data sets SAS7 BDAT raw data sets to the R programming. So here we have a paste 0 functions. Basically if you have any paste, any concatenate function, so we need to get this one, like, so we have to put pathra here. Then we're gonna use demo. This is the raw we're gonna use. So basically what I'm trying to say here, I'm reading the data sets from the raw data sets, so in our environment, because the raw data sets in the format of SAS7 BDAT. Okay, so this is in the SAS dataset. These are SAS datasets, not our datasets. We cannot directly access. So we need to convert. Into the R environment. We need to have a function called read SAS. Okay? Demog.raw SAS7BDAT. Okay. Now we're gonna use the similar one to import other datasets. So for example, I'm gonna import exposure datasets. Then I'm gonna use randomization dataset. We need to basically we can bring what are the datasets we required. We don't need labra, we don't need AERA, so we don't need demo dummy, we don't need vital. So we need only exposure raw and the randomization dataset for the treatment. Okay, so can I use a similar one, and so R&D, I think R&D dot sub. So let's control. Okay, so here we have a small mistakes because we got an error here. So basically if you want to access the raw dataset folder, we need to keep some more files. We have to go inside, right? So we forgot this one. Then we see DM datasets. For the environment here, we have a DM dataset here. Then we have the exposure dataset and random. Let me open these datasets. So we have all the informations are here. We go exposure datasets. We also have all the raw datasets what we need. Okay, now let's continue with doing this individual variables as per the specification. So here what I do, I don't need this part, just hide them for now. I need this part, I don't need this part. I gonna hide them, and gonna hide this part as well. Gonna use control terminology, the type. Okay, so let's do like this. So I just copy all this part, font. Okay. So based on this specification, I'm gonna continuously checking each how we deriving the programming derivations for each study, each variable name, So let's continue with the study ID first. So in order to make a comment, you should need symbol. I mean the hash pound, sometimes we call it pound or hash symbol. So the creating the demographic data set. So DM1, DM. So basically, we are trying to okay. So we need one more operator we call as a pipe operator. This is a pipe symbol. Basically, this is a DM dataset we are reading from here, and this is a new dataset name. This is similar, works similar like set dataset. So this is the DM dataset, and this is the pipe symbol. The pipe symbol is represents to continues the operation. Okay. So here we have now in order to derive or assign any variables in our language, we should use mutate function. Okay. Right. So make sure we should have understand that. So these variables, how it represents are here. So you should have to use the same case. Cannot be used as a lowercase or cannot be used as uppercase. If it is uppercase, you should have to use uppercase. If it is lowercase, you should have to lowercase. Don't be mixed up with it because this is case sensitive in our language. Okay. I'm gonna use the first study ID. So study ID. So we're gonna use the trim ws, which is the strip function. It's similar like strip function. So what I can do, I just like this. Easier for me to write like that. So the raw dot study. Here the programming comments and the derivation has not been clear, so we don't need to worry. I'm just trying to explain you how we derive each individual variable. Okay, so here we're gonna use study as per the DM dataset study. So then we continue with other, the domain. We continue with same thing, domain. So the domain should be DM as assigned to DM. Then we continue with subject ID. So the trim ws raw dots demo dot subject ID. So subject ID. Then we're gonna use site ID. Right. So next we're gonna continue with unique subject ID. So we have to use concatenate function phase 0. Okay. The combination of study ID, site ID, and subject ID. ID. Sorry. Site ID. Maybe bit like understand. Then we have So in between we have hyphen mark, so we're gonna keep it as like this. So after this, we can continue. We can check if it works. There any mistake? Okay, so we got an error here. So it seems like this is the problem. So we don't have study ID. Wrong ID. Name. So let's check the DM one. We have study ID, domain, site ID, and this is the concatenate of any subject ID. Okay. So these three are for site ID are done. So let's continue with the remaining part. Okay, so we're gonna use age right now. The date parts we're gonna keep it aside. We're gonna continue with age unit. Then the other variables, the age unit, sex, race, ethnic, forms. We're gonna continue this part first. Then we're gonna continue with standardized dates. Okay. Okay, let's continue. So age unit, sorry. Okay, let's since it's taking a long time to explain and writing the scratch code. So what I do, I just copied what I practiced it, and then I try to explain each individual syntax. So here we have age unit. So based on the specification, we have age unit here, right? So this is set to years as per the CRF and control terminology. So if you go to the control terminology, and if you just look into the control terminology here, age. So you can see here it is in the capital letters. Okay, it is in the capital letters and it representing the submission value as in years. So that's why we keep it as years. Then we continue with the age, the next variable age. So this is age, and here we have to set to value as age unit in the numeric format. So we have to strip like compress this one in the numeric format. So if we open the DM datasets, so if you open the DM dataset and you can see age units in this the numeric format. So basically it's a numeric format. So we keep it as it is. Is it in the so let's continue with other variables. So here we have race variables. The race variables. So this function we call it is basically is a upper making like capital letters. Okay, so case making the uppercase by using the structure to upper for the variable called ETH. So when you check the and this is in the character format. It's the raw.eth. So if you check DM datasets, so ETH it is in a prop case. So we need to convert into the as per the city we have to be let's check open the variable. So you see here submission is in the capital letters, not in this prop case. So we have to change to the uppercase for ETH. So now we're gonna continue with the date one. So these three are completed. Age unit, race also. So we're gonna use continue with the and the dates. reference standards, reference end date. These dates we are going to continue. So the RF-STDTC is the subject, reference, start date, and time. So whereas RF-ENDTC is subject, reference, end date, and time. So this is the first study treatment, and this is last study treatments, and this is informed consent, and this is end of participation. So these 4 dates are very important to derive. Okay, let's continue with this 4. So here we have concatenated with enrollment date and time. So RF-STDTC, we have enrollment date. Open the DM datasets for the raw dataset. So we have here we have enrollment date and enrollment time. So we're going to use this part to concatenate as per the specification. So here we are trying to convert into the character format, because this these dates in the character format, so we need to convert all of them into the character format. The enrollment date, and this T represents the time separation. Okay, so enrollment time. Then we have RF study reference end date. That is also, right now we don't have end dates, so basically seems like they don't have end date, so we're going to keep the completion date. Here we have completion date and completion time. For now we're going to keep the same thing, completion date and completion time. So when you come to the reference informed consent date, so we're going to use so basically there is no information, so we're going to use that date present in the DM raw dataset. So we have informed date and informed time. So we're going to use the similar like how we're doing with reference standard, reference ended. So we're going to use the concatenate functions, and we are changing to the character format. Then we are combining with the time by separating with the T as a capital. Okay. Then when you come to the end of termination, so whenever we don't have separate variable, there is no notes for this one as well. So we're gonna use the completion date and completion time as per, because there is no nodes are present. So we're gonna use the similar, that is for end of participation, right? So here we're gonna use the similar. So now for the death DTC, so these 4 are done. Let me check the informed consent. There is some nodes are present. So whenever we don't have separate variable from consent, we can directly assign enrollment and enrollment time. What does that mean? Whenever we don't have separate variable, so if we don't have separate variable, we directly assign to the enrollment date. But here we don't, we have informed date and informed time, like, right? So we don't need to be use enrollment date and enrollment time. So for that is okay now. Hope you understand. Let's continue with other variables. So the death DTC and death value. So set to missing right now, we will be update if any. Basically these 2 variables are set missing. We're going to keep it as set missing because we don't have that information in the raw dataset. Have that information here. We're going to keep it as it is. Now we're going to have the investigator name and investigator ID. Continue with these 2 for investigator name. So in the investigator name, we have any investigator variable are given. So here we see there is investigator ID there, and investigator investigator name and investigator ID is present there. So we're gonna directly map those things here. So now let's continue with the other variables. So we have so this is done. Oh yeah, investigate ID. So now we have the 6 variables. So the 6 variables basically is asking for as per the control terminology. So when you check the control terminology, if it is given in the female prop case F small, the initial letter or capital letters of female, we have to be represented in F format. Okay, so let's check in the raw data set how this is given for gender variable. Okay, so it is giving in the prop case, so we need to convert into this submission part. Okay, so if it is structured like uppercase of gen is in a female, then we assigned operator, there is this we call as, okay, so this is this symbol we call as a tilde symbol. Basically it is assigning like the value for that particular, if it is in this case when, here we have case when functions. The case when function is similar, like it works like if else, the statements in SAS programming. So the case, how do you, it's a similar like SQL, like for example if it is a female, then how do you represent in the output is F. If it is a male, then represent as a, if it is nothing, then we represent that as a missing. Okay, now we're gonna select only the variables, whatever the variables we are done with this data sets. So we select those ones, the domain, all of those stuff. So let's run this part up to here. So control enter. So we have dm1 here. So now we got all those variables, whatever the select statement we keep, all those variables are present here. Okay, so the select statement is basically works similar like procsql to select how many variables you are selecting. So those ones. Okay, let's continue with the remaining variables. So far we did done. We're gonna continue with the exposure variables right now. So arm, cd, arm, actarm, all those ones we have to derive. So this project is all about 2 periods, the crossover study. Basically, we have 2 individual studies. I mean, two drugs we're comparing. So it has given in a different periods. So we divided as period 1 and period 2. So we need to continue, we need to get extract those treatments, what are the given in the period 1 for the subjects, and what are the treatments are given in the period 2 subjects. So here we use some common variables, so study ID, subject ID, unique subject. So this is the set data set, like this is the raw data set we derive here, right? So we derive here for patra, the exposure raw data sets. So we're taking from that and we're using the pipe symbol, and we continue with the mutate, which is continuing that variables we have to get. And here we have few variables we already derive here in the DM datasets. Basically we're considering these ones to merge, to join at the end. So to join ex1 with the dm1 with the common variables. So for that reason we have to keep this one. Okay, let's continue with the those date. So there is a those dates, so we're gonna use the exposure dates here, right? So this is the those date, and this is in the character format. So you see here is this character format, so we need to convert into the numeric because we need to get the date for the start date of the treatment. So dsdt mdy function we're going to use. Mdy functions, basically it gives like month, date, year format. Okay, so rfxtdtc, the format dsdtn. Okay, dsdtn, then we have to use year, month, date format because rfx is in is 8601 format. Let's check the 8601 format here. Seems like we don't have that information here, but the IS8601 is giving this format, year, month, and date format. and the DSDTM, that is in the time. So we're gonna give hours, minutes, and seconds. And there is a separator for the T is a separator for this. So how we do here, the T is a separator for the time and date, and we do the similar like here, because this is in a different format, because we are applying the formats for these states. Okay. And then we filter visit. So filter function, it works similar like where function, because in the EX we are considering only those records the subject has in the period 1. Okay, the visit wise. So here we have two period 1 subjects as well as period 2. So we are separating, like, because this is in the crossover study, so we are separating the two treatments, right? And we are considering only those subjects and the start dates of those treatment and the TRT. The TRT is for those period 1. So here we have period 1, right? So here we have what are the treatments are given in the period 1. So we are considering only those records. Okay, so then we're gonna do the similar for EX2. So we have to do the same for EX2. So let's run these two first. EX1 here. We got all those records. So the total is 47 records are present. So remember we have 48 subjects, right? So when compared to the EX2 now, there, this is also 45 entries. So we got all those two separated. And here also we are considering the study ID, subject ID, site ID. So these are coming for common variables, right? The common variables to merge the two data sets. Okay, let's combine these two merge EX1 and EX2 by with full join, and by using the common variable as unique subject ID. Okay, so then we have a muted like pipe symbol. We continue with the pipe symbol. So RFX ENDTC now. So for RX end date, here they have given, oh, there is no. So basically RFXE and DTC, if we have any missing values, we are trying to remove those ones because we don't need any missing values here. If else RFX, then if it is a missing value, then RFXS DTC. So because it is the treatment has given in the same day. So if it is RF, like end date is present, if there is no end date, then we keep it as RFX DTC, and if it is an end date is present, then we keep it as end date. Okay, you understand, right? If there is a missing values, we keep it as a start date, as end date, and if there is no missing value, we're gonna keep it as a end date. Okay, for RFX and DTC. Okay, let's run this one. Now we're gonna combine the merge with exposure 3, this data set with the DM1 by using the left join, because the DM1 is the main one. We need all the records from the DM1, so we're merging with the DM1 first by using the unique subject ID. We got DM2. So let's check. We have 48 observations here. We checked all of them is 48 subjects. So we have treatments on treatment related information as well is present here. Okay, so now we have randomization data set because we need to assign the treatment sequence right now. So we have ACTOM, CD, ACT, those ones we have to assign. So we need randomization data sets. So this is arrange function. So basically it is sorting by subject ID wise. So before you merge, we have to sort the data sets. So it is sorting ran data sets. So we sort ran data sets, and we do DM2 as well. Then we combine with left join with the DM2 with the subject ID. Okay, if we check the ran data sets here. Okay, so here we have the final data set with ARM logic. So ARM CD, ACTOM, actual ARM CD, ARM, ACTOM, and I'm sorry, so this part. So these four we have to derive. So here base. Okay, there is no nodes here, so that is fine. Okay, let's go with so what is basically, if we check the RAN data sets, we have graph and test. So we are going to do R and T. If it is start with the treatment starts with ref, and the treatment one is start with the test, because these two treatments are period, right? So here is the treatment one is the period two, and the treatment is already there for the period one. So basically, if it is both, or if it is case when, like if it is both our ref and test, we are representing by using the tilde symbol. So here R hyphen T. So this is the representation purpose. We are giving that treatment as like this. So here you have to understand, when you're assigning the case when, so we have one single column, single equal symbol, and when we are representing, when we are assigning the value from the variables, like from the TRT, for example, you open tx1. So when you representing this one, okay, there is a truncations here, but it's okay. So when you represent individual variables, so you have to use a double quotes, double equal. Okay, so this is very important. And here we have AND operator, and then if it is this assigning, and if it is the test first, then ref, then we are using the this assignment. Okay, and if there is nothing, so we have to use mention as a NA for character. Okay, this is one of the functions we call. And for actom also, we because this is actom, this is a derivation point, this is in the shortcut, so we do this. If it is a ref and test, we use as a ref in the complete form. Okay, then we're gonna use the country, the variable. So these four are done, because arm cd arm, so we already assigned here arm dp, the RAND data sets, we have arm dp, right? And for arm, we are assigning the rmp. Okay, okay, this one is done. So now we have used country, the country variable, just because we don't have any DM datasets, like in the DM raw datasets, we have country. So there is no variable here, but what the specification is saying. So basically, this concept is present in this project is done in India, so we keep it directly IND is a. Let me open the control tab. Better clear. Don't be confused. Country. So this is the 3 times format. So whatever, if it is reported value, so it should be in 3 letters. So that's why I'm keeping the IND. Now we select all those things, whatever we required as per the specification. So we got these two part, ethnic, there is no thing. So let me check in the DM raw dataset. Have ETH that is in the supplemented dataset we get. So for now we don't have ETH ethnic part, so we're gonna keep it as for now, not required. Then we have DM data time collections. So these we're not going to do right now because there is no study date. There is no given, and these are not required as well. The birth DTC. I think birth DTC also we don't need, because we don't collected the information in the raw data sets. I guess we have that information. Have that. So all those variables we got. Have this in. The remaining all we have derived and assigned. Let's run this part. So this is the final datasets. TM4. Total 48 subjects and 25 columns. So we get all the required. So you see ARM, DP, ARM, ACTOM. So we have, there is missing. So we keep it as NA, because this is we consider one. Okay, so the DM4, let me open the DM4 here. So in the DM4, I see some ACTOM CD and ACTOM, they are missing. The reason, because let's check this subject, S10 subject, right? So when you open the treatment for X10, so you have in the period 1 they have given the test test drug to the patient subject, and in the period 2 they don't have any drug. For that reason it is coming as a because there is no sequence, continuous sequence for that one. So for now we're not assigning anything. So for this case we just keep it as NA right now. Hope you understand. So in the treatment for this subject, the period 1 they have given the tested drug, and the period 2 missing. So that's why in the actual arm CD this is missing here, NA. Okay, then we continue with the variables right now. As per the specification here, we get all these variables copied, we paste it here, and this is the function we call vasta table. And if we have multiple variables, and we need to keep as C as a before we start doing this label. Okay, and once we get all those labels, then we have one package we call. So let me run this one first. So this is the library HMIC, and we update for the DM final dataset with this label. Okay, call this library, then update. So when you open this final dataset, so you see here giving all the information, all the labels for each individual variable. Okay, then we have to save it in the dm.rdc file. Okay, dm file equal to RDS. So this one will go save here in this R clinical. Okay, so this part will go save here in our clinical course. We have RDS, so we're gonna create a new data set for the final data set. I'll save it here. Okay, that's it for now. This is a DM dataset. We're gonna continue with the other datasets. Thank you for listening.